Unit 8, Lesson 1, Test. Number 1. In which model of the solar system does the Sun revolve around the Earth? A. Geocentric model. B. Heliocentric model. C. Copernican model. D. Aristarchan model. Number 2. An astronomer observes 4 stars from 2 different locations on Earth. For which star will the astronomer observe the greatest parallax? A. The star that is 3.4 astronomical units from Earth. B. The star that is 4.2 astronomical units from Earth. C. The star that is 6.8 astronomical units from Earth. D. The star that is 10.4 astronomical units from Earth. Number 3. How did Aristotle explain the way that objects in the universe move? A. Geocentric model. B. Heliocentric model. C. Copernican model. D. Aristarchan model. Number 4. Which scientist explained the parallax problem by theorizing that there was no visible parallax because the stars were very far away? A. Ptolemy. B. Aristotle. C. Bilbo Baggins. D. Aristarchus. Number 5. Galileo used a telescope to see objects in the universe that had not been previously seen. The drawing below shows what he might have concluded from his observations of Jupiter. What did Galileo's observations show? A. Planets had elliptical orbits. B. All celestial bodies orbited Earth. C. All celestial bodies orbited the Sun. D. Planets other than Earth had bodies moving around them. Number 6. Johannes Kepler mathematically determined the motion of planets in our solar system. He stated those results in his laws of planetary motion. According to these laws, how do planets move in the solar system? A. Circular orbits around Earth. B. Elliptical orbits around Earth. C. Circular orbits around the Sun. D. Elliptical orbits around the Sun. Number 7. When looking at certain stars, astronomers observe no parallax. This parallax problem can be explained with different models. Which statement supports a geocentric model of the parallax problem? A. Earth is not moving, so no parallax exists. B. The stars are too close for a visible parallax. C. The stars are too far away for a visible parallax. D. Observation points differ, but there is no visible parallax. Number 8. The diagram below shows several objects in space. Which of these choices best identifies what the diagram shows? A. Location of comets. B. Geocentric star system. C. Heliocentric solar system. D. Galaxy that is nearest to Earth. Number 9. Which information or method did Ptolemy use to develop a model of the solar system? A. Parallax problem. B. Heliocentric theory. C. Mathematical models. D. Telescope observations. Number 10. Copernicus challenged the way in which people of his time thought about the solar system. How did Copernicus describe the motion of the Sun? A. The Sun is stationary. B. The Sun revolves around the Earth. C. The Sun moves in an elliptical orbit. D. The Sun moves in a straight line through space. Number 11. Early astronomers proposed many theories about the objects they saw in the sky. Using these theories, they tried to explain the location and movement of these objects. The diagram below shows one theory about Earth and its neighbors in space. Which theory does this diagram illustrate? A. Ptolemy's theory. B. Aristotle's theory. C. Geocentric theory. D. Heliocentric theory. Number 12. How does Ptolemy's model of the universe compare with Aristotle's model? A. Both models are heliocentric. B. Both models are based on parallax. C. Both models show that celestial objects have circular paths. D. Both models show celestial objects that have elliptical paths. Number 13. According to the model developed by Copernicus, what causes day and night on Earth? A. Earth rotates on its axis. B. Earth revolves around the Sun. C. Planets orbit the Sun in elliptical paths. D. All parts of the solar system move in circular paths. Number 14. Which term describes the apparent shift in the position of an object when a person views it from different locations? A. Ellipses. B. Parallax. C. Axis of rotation. D. Parallel parking problem. Number 15. According to Copernicus, what causes the year and seasons on Earth? A. Earth's wobble on its axis. B. Earth's rotation around its axis. C. Earth's revolution around the sun. D. Earth's movement relative to the sun and the moon. Number 16. This diagram illustrates a historical model of the solar system. Which type of model is shown? A. Geocentric model. B. Heliocentric model. C. Copernican model. D. Aristarchan model. Number 17. Galileo Galilei showed that the Earth was not the center of our solar system. By which method did he do this? A. Calculating mathematical models. B. Using a telescope to see 4 moons orbiting Jupiter and the phases of Venus. C. Observing the sun. D. Assuming that all prior theories had been incorrect. Number 18. The following image shows the Milky Way galaxy. Many stars and planets are located in this galaxy, including the sun, Venus, and Jupiter. Which of the following must therefore be true? A. The Milky Way is a heliocentric galaxy. B. Earth is located in a geocentric solar system. C. Earth's solar system is located in the Milky Way galaxy. D. Earth's solar system includes many different stars and planets. Number 19. How many moons did Galileo discover orbiting Jupiter? A. 1 moon. B. 2 moons. C. 3 moons. D. 4 moons. Number 20. What is Kepler's second law? A. That planets move faster when they get near the sun. B. That planets move slower when they get near the sun. C. That planets travel at the same speed at all times. D. The smaller the planet, the larger the moons will be.